Okay, today's topic is we want to look at a one-sided limit. And I know before when we talked about a limit, we said we were looking at the limit from the left and the right. Well, now we want to look at the limit from one side. If we're given the following function, negative x minus 2 squared plus 4, we have our quadratic function, which has a graph of a parabola that's opening down. And the first example is we want to look at what's the limit of this function as x approaches 2, but this little negative sign here in the exponent, this is telling us that we want to look at the limit as x approaches 2 from the left. So that means we're looking from the left-hand side of 2. So we're looking at the left side. So as we approach 2 from the left, so values that are smaller than 2. So if we're approaching 2 from the left, what is our y value approaching? Well, as we get closer and closer to 2, our y value is approaching 4. Okay, so that is our one-sided limit. Down here in green, we're looking at the limit of the function as x approaches 2, and this little plus sign here says we're looking at the limit from the right. So if we approach 2 from the right, that means we're looking to the right of 2. As we get closer and closer, once again, we're approaching 4. And down here in orange, we have the limit of the function as x approaches 2. If you notice, there's nothing up here. There's no plus or minus in the exponent. So that tells us that we're looking at the limit from both sides. Okay, so we're looking at it as a two-sided limit. We're looking from both sides. So if we're looking from the left side and from the right, as we get closer and closer to 2 from the left and the right, we're approaching 4. Okay, so that tells us the left-sided limit from the left and from the right. If they're approaching the same number, then that tells us our limit exists as x approaches 2. So therefore, the answer for the two-sided limit here is going to also be 4. Now, you may ask, why do we want to look at a limit from one side? Well, if we look at the following function, the square root of 4 minus x squared, we have half of a circle here going from negative 2 to 2. And if we want to look at what's happening as we get close to a negative 2, if you notice here, why did I use the little plus sign? Well, because we want to look at the limit as x approaches negative 2 from the right. Why do we want to look at it from the right-hand side? Well, there's no values from the left. It wouldn't make any sense to approach from the left side because there's no graph, there's no x values to the left of negative 2. The function stops at negative 2. So this is an example where we want to look at the limit from one side. So if we look at the limit as we approach negative 2 from the right, what are we approaching? Right, we're approaching our y value. We're getting closer and closer. Your y value is getting smaller, so we're approaching 0. So that's your limit. So if we wanted to calculate the limit of the function as x approaches a positive 2, what do you think we want to use there? Well, if we're approaching positive 2, there's no values to the right of 2, so we would want to use a negative to indicate we want to approach 2 from the left. And if we approach 2 from the left, again, what's happening? We're approaching 0. So that's your limit from the left-hand side of 2. All right, so here we have some function. All I have here is the graph. So here we have some function. We don't know what the function is, but it's several piecewise functions here. And we want to look at the limit of this function as x approaches 2 from the left. Okay, so here's 2. If we approach 2 from the left, our y value is getting what? It's getting closer and closer to 1. And if we want to look at what's the limit of our function as x approaches 2 from the right, well, if we're approaching 2 from the right, once again, we're getting closer and closer to 1. So if we want to know then what's the limit of the function as x approaches 2, then since both of these are 1, this answer is also 1. So in order for this third limit, for x approaching 2, in order for this third limit to exist, the left side has to be approaching the same number as the right side. And in this case, they're both approaching positive 1. All right, if we look at limit number 4, if we look at this as x approaches 1 from the left-hand side, our y value is approaching 0. And if we look at the limit of the function as x approaches 1 from the right, notice now as we approach 1 from the right, this is the line here. As we approach it, as we approach this x value of 1, the y value is approaching 1. So from the left we have a 0, and from the right we have 1. Now what's the limit of our function as x approaches 1? Now remember, this says there's no exponent, there's no plus or minus here in the exponent, so that tells us we're looking at from both sides. Well, because the limit is approaching 0 from the left and 1 from the right, we're approaching two different numbers, so that means your limit here does not exist. So you need to keep that in mind. In order for your limit to exist as you approach a number from both sides, you have to approach the same number from the left and the same number from the right.